Hi there. So now we're going to talk about section 3.2. This is called the vertex of a parabola. Okay, so last time we were talking about quadratic functions and we were talking about parabolas and finding the equation of parabolas if we had the zeros. Recall that we have three different ways that we can write out the formula for a parabola or for a quadratic, either way you want to call it. This is called standard form. It doesn't give us any information outright, but it is still very useful. Another form that I mentioned, notice I'm using f of x and y interchangeably. Please don't let that mess you up. We can use those interchangeably. Is we had it written this way. Now, the beauty of it written in this form is we have our zeros right away. In other words, our x-intercepts. And there was a third form that I mentioned last time, and this is the form we're going to look at in this section. Okay? This form we use when we have information about our zeros. This is the form that we use when we have information about our vertex. Now, you may or may not recall what I mean by a vertex, but your vertex is either, if your graph opens up, it's the minimum value on the graph. If your graph opens down, it's the maximum value. But the other interesting thing about your vertex is essentially if you draw a vertical line straight through your vertex, one side of your parabola is a mirror image of the other side. Okay? So again, if we could fold this along this vertical line, it's called our axis of symmetry. But if you fold your graph along this vertical line, you'll see that whatever happens on one side, exactly the same thing happens on the other side. Okay, now, what I'm going to do is let's first take this quadratic, y equals x squared minus 1. Now, we're going to go back to some vertical shifts and horizontal shifts that we talked about in a previous section. Again, both the beautiful thing and the nemesis of mathematics for people is you can't forget anything. You have to remember everything you ever learned. So, recall when you add or subtract a number outside of your function, that gives you a vertical shift. In this case, what we would do is take our basic graph of y equals x squared and move it down one. Okay? And there's our graph. Okay? We know that ordered pair is 0, 1. Precisely because at first we were at 0, 0, and then when we move it down 1 unit, we're at 0, negative 1. Now, what I want to do is take a quadratic in this form and write it in what we call vertex form. Okay? I claim there's not much to do here because really the equivalent way we would write it is x minus 0 squared, which is simply x squared, and then we have the minus 1. Okay? Why did I do that? Well, notice this value here is 0, negative 1. Lo and behold, that gives me my vertex. Okay? So, the beautiful thing is when you have a parabola, the equation written in this form, again, your A tells you whether it opens up if it's positive or opens down if it's negative, but your vertex is HK. And that's a pretty cool thing. Now, How, you might ask, in general, do we take a quadratic written in this form and write it in vertex form? That's why in section 3.0 we talked about completing the square. Okay? Now, one other quick comment that I want to make in terms of one of these graphs, and then we'll play with a bunch of examples, is as follows. Suppose I have my quadratic already written in this form. Okay? Let's take what we already know about our shifts and see how that applies. Notice I told you that the vertex is HK. Now in standard form, we have a minus. So you can look at this as x minus a -2. And I claim from that we see that our vertex is -2, -3. A lot of times students tell me that the way they think of it is change the sign of what's inside and then take that other value. Okay? Now, what does the general graph of y equals x squared look like? Again, that's our general parabola here. What did we learn about our horizontal and vertical shifts? Well, remember, when you add a number inside of your function, you see if f of x is x squared, I claim what we're doing is looking at f of x plus 2 and then minus 3. Okay? Let me show you that that's in fact what we're doing. Again, if f of x is x squared and we want to look at f of x plus 2, everywhere where we see an x in our function f, we're going to plug in x plus 2, and then we subtract 3 after. Okay? But what did we learn about our shifts? Well, when we add or subtract within our function, that's our horizontal shifts. And when we add or subtract outside of our function, those are our vertical shifts. So, just by using the notion of shifts, I know since I'm adding inside, I'm going to take my basic graph, go left 2, and then go down 3. Okay? So, if I take my point on my general graph, my vertex of 0, 0 here, and I go left 2, well, that's going to bring me to -2, 0. And then go down 3. Well, I'm still at -2 for my x value, but now I'm down at -3 for my y value. And you can then graph your parabola. Okay? So, again, our general form to read off our vertex is this, and that value HK is our vertex. So, let's talk about this particular example. Suppose you're given y equals x minus 1 squared minus 4. Okay? What I want us to do is first graph it using our shifts. And then what we're going to also do, just for the fun of it, is find our zeros. All right, so if we're going to graph this using our shifts, what do we know? Well, we know we're going to take our basic graph of y equals x squared, and we're going to go right 1 unit, I'm subtracting within, and down 4 units. So here's my 0, 0 vertex. I go right 1 and then down 1, 2, 3, 4. And there's our basic graph. Now, notice this is a little fuzzy here. We can refine that shortly. Okay? Notice using what we talked about with our vertex, it's 1, -4, and notice using our shifts, it's entirely consistent. All right. Now, how can we make this graph look better? I mean, one thing that we're solid about is that, yes, we are at the ordered pair, +1, -4. Okay? But now the other thing I want to do is find our zeros. What does it mean to find our zeros? It means that we want to take this quadratic and set it equal to 0 and solve. Now, when it's written in this form, we could say, oh, we want to know where is x minus 1 quantity squared minus 4 equal to 0. There's a couple different ways that we can proceed from here. One way is quicker than the other, but I encourage you to do whatever comes more naturally. Okay? One thing you could do is say, oh, let's get our squared term on one side and our constant on the other side. So I can add 4 to both sides, and I'll get 4 is x minus 1 quantity squared. Now to undo that squared, I can take the square root of both sides. The square root of x minus 1 squared is just x minus 1. And the square root of 4, you have to consider both the positive and negative values. So do you agree we get x minus 1 to be either equal to 2 or x minus 1 to be equal to -2? And then from here we can solve for x. We get x to be 3 or x to be -1. So even better, now we know that that goes through 3, 0 and -1, 0. Okay, got one more little detail left. But we did find our zeros. Now, what's another way that people tend to go find their zeros? Well, some people might not think, oh, I've got to, move my constant over and then I can take the square root of both sides. A lot of times people would say, oh, I need to multiply all this out, set it equal to 0, and cross my fingers that I don't have to use my quadratic formula and that I can factor it. Let me show you that what you get is exactly the same. Okay, and this helps us practice our algebra a bit. Remember, x minus 1 quantity squared says you're taking x minus 1 and multiplying it by itself. Well, let's FOIL that. X times x is x squared. Outside terms you get minus x. Inside terms you get minus x. Last terms you get plus 1. And then we have a minus 4. If we combine like terms, we get x squared minus 2x minus 3. Okay? Now, again, if we want to find the zeros, what we would do is take this guy, set it equal to 0, and lo and behold, we can factor it. Notice I need to find two numbers that multiply up to a -3. Since it multiplies to a negative, one is positive and one is negative. And then they have to add up to -2. So that tells me that my larger one is negative. Well, again, I have the product of two things equal to 0. So either the first one is 0 or the second one is 0. And I get x to be -1 and x to be 3. Which is exactly what we got over there. Now, when you do these on your own, you don't have to do this both ways. I like to show you guys options. Okay? Now, the other thing on our graph that we can note, having our quadratic written in this form, is we can look and tell what our y-intercept is. Okay? In other words, where the graph crosses our y-axis. How? Well, remember, your y-intercept is your value of y when x is 0. If I plug in x equals 0, -3 comes out. All right. So that is one particular example. Now, let's do another example like this. And then what we're going to do is learn how to find our formulas given various information. Okay, so the next example that I want to do is I want to take this function And all I want us to do is I want us to give the vertex and state whether our graph opens up or down. Okay? Well, what's my vertex going to be? Remember, change the sign of what's inside, so -3, -4. Okay? So I know my vertex is -3, -4. Does this graph open up or down? Well, notice my value of A is negative, and therefore I know my graph opens down. If I tried to ask us to find the zeros of this parabola, notice we can look at it visually and say, well, it never touches or crosses our x-axis. And in fact, if you multiplied this out and used your quadratic formula, you would see that underneath your radical you get a negative number, and therefore there is no real solution. Okay? Let me show you. Again, you can multiply this out. We have a negative. I claim if you FOIL that, you're going to get this. Okay? Do it on your own. You will see. Now we can distribute our negative sign throughout our parentheses. So we're going to get -x² minus 6x minus 13. Notice the number in front of our squared term is negative, as we saw up here, consistent with our graph opening down. Now, if I asked you to find the zeros, and I won't ask you to find the zeros where they don't exist, but you can't factor this, okay? But if you tried to find the zeros using your quadratic formula, let me show you what you would run into. Think you'll grant me your A is -1, your B is -6, and your C is -13. So if I plug that into my quadratic equation, x is -b, well, -6 is a +6, plus or minus the square root of b squared minus 4 times A times C all over 2 times A. That's how we would plug it in. Okay? Now, what do we get? I'm just going to hone in on the radical because we'll see that will be done once we approach that. You get 36 for -6 squared. And negative times negative is a positive times another one is a negative. You're going to get -52. Do you see how we have a negative number underneath our radical? 36 minus 52 is a -16. Okay? There is no real solution for the square root of a negative number. So notice the fact that we got no solution over there is consistent with our graph over here. Okay? Again, that's just kind of a little extra added, but I think it's good to see. All right. Now, what I want us to practice doing first is finding some formulas given a graph. Now, depending upon the information you are given, that will determine which form you use of those original 3 forms that I told you we can write our quadratic. For example, for the next few, I want us to find the formula for the parabola. And this first graph that we are going to look at has this information given to us. Oh boy, okay. You'll see why I'm saying oh boy momentarily. Oopsie, excuse me. Let me redraw that. I'm at 0, -3, but I want to be down here. All right. So, here's my vertex down here. This is my ordered pair, 0, -3, and then it goes through those two zeros. This is a situation that takes us back to our last lesson, okay? Why? Because notice, we're given our zeros, okay? You may or may not recall, but once you're given your zeros and an extra ordered pair, you can actually find the equation of your quadratic, okay? So, let me write it like this, x minus p, x minus q, okay? Remember, if 3 is a 0, then x minus 3 is a factor. If -1 is a 0, x minus a -1, aka x plus 1, is a factor. And we're one step away. What we need to do is find our value of a, and we can do that by plugging in this ordered pair. We see that when x is equal to 0, our y value is -3. So I get -3 equals a times -3 times a positive 1. So I get -3 is equal to -3a. In other words, a is 1. And there's the equation. Notice my a is positive, my parabola opens up, life is pretty consistent. Okay? So again, you're going to use this form of your quadratic when you're actually given your zeros. Now, suppose you're given this, and again, we want to find the formula for our parabola. Okay? Let's suppose, well, first off, let us know that none of my pictures are ever drawn to scale. Suppose that's -6, 9. And the other ordered pair that we're given, well, we're given that it crosses our x-axis over here at -15. Okay? Notice here, we're not given our zeros, so this form isn't going to help us. Yeah, we're given one of them, so we know that one of the factors would be an x plus 15, but we do not have enough information to get the other one. So, when you're given your zeros, this is the form you want to use. When you're given your vertex, this is the form you want to use. Okay? My vertex is -6, 9. So at this point, I don't know my a yet. I have x minus my h value plus k. So at this point, I have x plus 6 squared plus 9. Remember, when it's written in this form, hk is your vertex. All right. The only thing we have left to do is find the value of a, and again, just like in our previous example, you need to be given another point. In this case, we're given the ordered pair -15, 0. In other words, y is equal to 0 when x is -15. Okay? So let's go through and solve this. We have an a on the outside. -15 plus 6 is a -9. We have to square him first, so we get times 81 plus 9. In other words, what we're solving at this point is 81a plus 9 equals 0. We can certainly solve for a here. First thing we do is scoot our 9 over. Now to get a alone, divide both sides by 81, and I claim you're going to get -1/9. So our final answer here is -1/9 x plus 6 squared plus 9. Notice we got a negative value for a. which is entirely consistent with the graph we have because it opens down. And you just have to admit that life is really sweet how things work out so consistently in math. Okay, so let me do one more here, just to be sure that you guys are okay with this. Suppose now, here's our parabola. That's the point 2, 0. And this is 0, negative 4. Can we find the equation? And I claim absolutely. Okay, again, we're given our vertex, so we can just plug that right in. We have y equals a times x minus 2 squared plus 0. Now, am I going to keep this plus 0? No. So right now we have x minus 2 quantity squared times a. Okay, to find our value of a, I plug in the ordered pair negative 0, negative 4. In other words, when x is 0, our function value is negative 4. So I get negative 4. Well, negative 2 squared is 4 times a is 4a. I'm going to get a to be negative 1. So my final answer here, you could put negative 1 or you could just put negative. Cool, huh? And notice you're subtracting 2 within your function. It tells you you move it to the right 2 by those horizontal shifts we talked about. And then this negative in front tells us that we open down. All right. Now what I would like us to do is the following. What I'm going to do is I'm going to give you a quadratic in general form, and what we're going to want to do is put it in vertex form by completing the square. Okay? This is like the one situation where you got to complete your square. For example, suppose I have this function. Okay? That's a quadratic function. Already I know, oh boy, my graph opens up. Okay? How do I know that? Because the number in front of my squared term is positive. Okay? Now, this goes back to our review about completing the square. Remember, the first thing you do is you need a 1 in front of your squared term. Okay? If you don't have a 1 in front of your squared term, you're going to need to factor it out. Don't worry, we'll do an example where we actually have to do that. At least my hope is. Okay? So, let's go through this. Well, how do we put this in vertex form? The first thing that I'm going to do is separate my first 2 terms from my last term. Okay? So, for example, if there was a number not equal to 1 in front of your squared term, you would only factor it out of the first 2 terms. Now, from there, what we're going to do is complete the square. Okay? How do you complete the square? You take half of your middle number. Remember, I always told you, write it off to the side. Half of a positive 8 is a positive 4. And then what we do is we square it. Well, I think you'll grant me that if we square our 4, we're going to get a 16. Now, the thing is, I've changed the value of my function and I can't do that, right? I mean, if I got rid of my parentheses now, I suddenly have x squared plus 8x plus 19. That's not what I started out with. This is where that whole balance idea comes in, okay? You can't add something here without subtracting it out here, okay? Now, our next plan is to write this as some quantity squared. And we're going to get a minus 13 out here from 3 minus 16. What number goes right here? Remember, that's why I always encourage you to write half your middle term off to the side. We had a positive 4 there. So, By taking our general quadratic and putting it in this vertex form, I know my vertex is -4, -13. Right? Take your graph of y equals x squared, shift it to the left 4 and down 13, and we got it. Isn't that cool? Okay, so let's do another one. All right, so what if now I have the following? Y equals, how about this? -2x squared plus 4x plus 1. And suppose I wanted to put this in vertex form. Okay? Well, what would we do? Remember, you want to group your first two terms together. Notice, I don't have a 1 in front of my squared term. So all I'm going to do is factor it out of my first two terms. So I'm going to take this -2 out, and 4 divided by -2 is a -2. Okay, now let's look at what I've written so far, because I claim what I have is equal to what I had up here. It's just written in a different form, right? -2x squared plus 4x plus 1. Okay? Well, now what we do, and you got to pay close attention here, is we take half of our middle term. What is half of -2? That's -1. I always write them off to the side. And what do you get when you square -1? You get a +1. Okay? Now we still have this +1 here. But let me say something. Just because we added 1 here doesn't mean we're going to subtract it out here. You might ask why. That's what we did over there. We added 16, and so we had to subtract it. The key thing to keep in mind is when you factored a number out, if I remultiplied this out, I didn't add 1 to my function. If I distributed this, I'd see that I actually subtracted 2 from my function, because -2 times 1 is -2. So, key thing, keep in mind the constant that you factored out. We've essentially subtracted 2 from our function, so we need to add 2 out here. So what do I have? -2. I want to write that as some quantity squared, and then I have a +3 out here. Well, what number goes here? That's what we put when we take half of our middle term. And there we have it. What's our vertex? Whoa. Our vertex is 1, 3. Does the graph open up or down? I claim the graph opens down because we have a negative in front. And we'll see the effect that the 2 has. It turns out it just makes the graph thinner. Okay? All right. So just a couple more examples. What if I want us still to find a formula for a parabola, and suppose I give you this piece of information? Okay, what if I tell you that the vertex is at 4, 2, and it has a Y-intercept of 6? Can we write down what our formula is for our parabola? I claim we absolutely can. Okay, since we're given the information relating to our vertex, I know that this is the form I want to think about. Okay? Well, we have our vertex is 4, 2. That gives us our H and our K. How do we find our value of A? Well, again, that's the beauty of this extra piece of information. If we have a Y-intercept of 6, doesn't that mean that it goes through the ordered pair 0, 6? In other words, our Y value is 6 when our X value is 0. Okay? Well, let's go through and solve this. 0 minus 4 is negative 4. If you square it, you get 16. So we have 16a plus 2. And we can certainly solve for a. First thing we do is subtract 2 from both sides. So we get 4 is 16a. Divide both sides by 16, and we get a to be 1/4. So the equation for this parabola looks like this. And again, we know in our mind's eye what the basic graph of this guy looks like. Again, we take our basic graph of y equals x squared going through 0, 0. And this says move it to the right 4 and then up 2. And we know it opens up because our a value is positive. Not a very precise graph, but it certainly gives us an idea. Something else I want to point out. Notice there's no zeros here, are there? There's no place that this graph touches or crosses our x-axis. And again, if you were actually to multiply this out and then use your quadratic formula to find the zeros, you'll see that you're going to get a negative under the square root again, just like we did in an earlier example. All right, one more example for this section. Again, we're wanting to find a formula for our parabola. And now, though, we are going to be given that there is a single x-intercept at 1/2 and a y-intercept at 3. Okay, now notice we have that form when we're given the vertex. We use that vertex form. Okay, now we're told that there is one x-intercept. This is where it's really important to make the connection that your x-intercepts are your zeros. So, because you're given your x-intercept, aka your zeros, you're going to want to use this form. Okay? Now, we're given that there's a single one, so we could say that's x minus 1/2 times x minus 1/2. Alternatively, you could write that as y equals a times x minus 1/2 squared. Okay? These are exactly equivalent. Now, only other thing we need to do is find our value of a, and lo and behold, you just need to be given some random ordered pair. And in this case, we're given our y-intercept, which we can then translate to the ordered pair 0, 3. And again, whichever form you want to use, you're going to get the exact same thing. I'll just use this form because I'm standing here. Notice when x is 0, we have y to be equal to 3. All right, we can solve this. 0 minus 1/2 is a negative 1/2. And negative 1/2 times negative 1/2, I claim, is a positive 1/4 times a. How do we solve for a? Well, what we would do is multiply both sides by 4, and I claim you get a to be 12. So, that is the equation for my parabola. And that completes this section. Thank you.